Hey Bobcats, I hope you're doing well. Yesterday, we took a look at the experimental probability of flipping a cup, and hopefully you understood by the end of the video that experimental probability is used to make predictions. The outcomes aren't necessarily going to follow the experimental probability that we've come up with, but it usually gives us an idea of what kind of trends we might see and what our outcomes might be. So we're going to look at a couple of examples today and make some predictions. So Allie's Cookie Connection sold 16 cookies, of which 8 were oatmeal cookies. Considering this data, how many of the next 10 cookies sold would you expect to be oatmeal? All right, so what we're going to do is we are going to, here, let me get my text going. We're first going to find the experimental probability of an oatmeal cookie being sold. So we have the experimental probability of oatmeal. Well, we know that 8 out of 16 of those cookies were oatmeal. So our probability would be 8/16, which we should reduce. Okay, 8/16 is the same as 1/2. Now what we're going to do is we're going to take that probability of 1/2 and we're going to apply that to the 10 cookies. So if our probability of selling an oatmeal cookie is 1/2, then we can take 1/2 and multiply it by the number of cookies we sell altogether, which is 10. So 1/2 of 10 is 5. So what that means is you can expect to sell 5 oatmeal cookies out of 10. All right, so let's go ahead and look at another example. And just to review, first you're going to find the experimental probability from the data given. Then you're going to use that probability, multiply it by the number of trials, which in this case for number 1 was the next 10 cookies that were sold. And then you get how many we can expect to sell. Again, this is a prediction. You could have a family that comes in and doesn't like oatmeal cookies, and they buy 20 cookies, and then none of them are oatmeal. So this is, like I said, just a prediction. All right, the second one here says, on his recent batting attempts, Reese hit 6 balls and missed 10 balls. Considering this data, how many of his next 16 attempts would you expect Reese to miss? So let's go ahead and break this apart. First of all, we want to find the probability. So we're going to do the probability. You know, green is not a good color. That's too light. Let's do red. Okay, so the probability of a miss. Okay, so it says that he missed 10 balls and he hit 6 and missed 10. So that means that there were 16 attempts total. So it's going to be 10 out of 16 for this. Now we do want to take the time to reduce that fraction. It will make it a lot easier for us to deal with it. Looks like the top and bottom are both divisible by 2. So I can reduce this to 5/8. Okay, now I'm going to take that probability, 5/8, and it says, how many of his next 16 attempts would you expect Reese to miss? So we're going to multiply by 16. Okay, now if you can't remember how to multiply fractions times whole numbers, the way that I do it, and if you're using a calculator, you can do it this way too, is I take the numerator 5, multiply by 16, and then divide by 8. Okay, so I do 5 times 16 divided by 8. Because remember, there's that invisible one under the 16, and you multiply straight across. So you end up doing 5 times 16 on the top, 1 times 8 on the bottom, and then you can divide. So if you do that, you get 10. So what we're saying is that We can say we would expect that Reese would miss 10 balls out of the next 16 attempts. Okay. So all you're going to do the rest of the day is work in IXL. The problems are very similar to these ones I've gone over with you. If you have any, if you need any help, please reach out to your teacher and we'll try to get back to you right away with some clarity on these problems. All right, Bobcats, have a great day and we'll see you tomorrow.